Swayam Prabha. Digital India. Educated India.
So, last class I was discussing one example problem that where the SPT values are given with depth for a particular site, and then we have a foundation of 2 cross 2 a square foundation. Then we have to determine what is the allowable bearing capacity of that foundation or that soil. Now, this is the problem where this is the variation of n with the depth, and the depth of foundation is 1.5 meter and the water table position is 2 meter below the foundation. So, the permissible settlement is given 50 millimeter and the factor of safety is bearing is 2.5. Because the permissible settlement, why it is taken 50 millimeter? Because the as per IS code, the isolated footing on sand, the permissible settlement is 50 millimeter. So, that I have discussed in the last class. So, that is why I am taking the permissible settlement is 50 millimeter. So, now first case we have used the 10 correlations. Now, here this is the correlations. Now, we have to use the n value. Now, for remember that the for bearing, so this information is also very important, that for bearing capacity, bearing consideration, the influence zone is B, width of the foundation from the base of the foundation, and for settlement consideration, the influence zone is twice B, okay, from the base of the foundation. Okay. So, that means, when you consider the only bearing, then you will consider the influence zone of the foundation is B from the base of the foundation, and we will consider the settlement, then the influence zone is twice B from the base of the foundation. So, 10 correlation is only considering the bearing capacity, bearing consideration. So, our influence zone will be B from the base of the foundation, and for allowable bearing capacity where the permissible settlement is given. So, in that cut is the settlement is involved, then the influence zone will be twice B, remember that. So, now this case 10 correlations, the influence zone will be B. So, if the influence zone is B, so that means the B is the 2 meter and it is from base of the foundation. So, influence zone will be 3.5 meter from the surface, 2 meter B plus 1 meter, 1.5 meter, it is depth of foundation. So, influence zone will be 3.5 meter from the base of the from the surface. So, the influence zone will be, for bearing consideration, influence zone will be 3.5 meter. Now, for settlement consideration, the influence zone will be twice B. So, this will be 4 plus 1.5. So, this will be 5.5 from the surface. Okay. So, this 3.5 is only bearing consideration, influence zone from the surface, and 5.5 meter is the influence zone from the surface considering the settlement. Now, so that means we have to calculate the average n value. Okay. So, n average for bearing consideration. Okay. So, what will be the N average for bearing consideration? So, we have 3.5 meter influence zone. So, it is in between this. Okay. So, this is 3 meter, 3.75 meter. So, it is 3.5 meter. So, corresponding to 3.5 meter, this N value is around, corresponding to 3.5 meter, the N value is around 25. So, this is 20, this is 30, this will be 25, and corresponding to this 5.5, the N value is equal to 31. So, this is 30, 40, around 31. So, we are taking these values. So, now we will add these values. For example, for 1.5 meter, you have a 17 plus 2.25 meter 22 plus 3 meter it is 20 plus 3.5 meter 0.5 also we have taken. So, it is 25. So, the average value, this is 4. We have taken 4 readings. So, average value is 4, and all 4 readings are below the base of foundation. For example, suppose you have a reading of 0.75 meter, which is above the base of foundation. So, that reading is not required when you calculate this bearing capacity equation. So, we will consider only below the base of the foundation. Okay. So, now this average value is, if I take this is average value, only bearing consideration is 21. Similarly, N value, N average for settlement consideration. Okay. So, this N value is, we have again 17 plus 22 plus 20 plus 27, then 4.5 is 29, then 5.25 is 30, then it is actually 5.5. So, we are taking 31 also, and then we are taking the average 1, 2, 3, 4, 5, 6, 7 readings. So, average is divided by 7, and that average value is coming out to be 25. So, average N value for bearing consideration is 21 and average N value for settlement consideration is 25. So, we will use these values. So, now average N value we got. Now, we have to determine the RW dash and RW, and water table position is below the base of foundation. So, as I mentioned that our RW will be 1, because in that case dW will be equal to dF, dW is equal to dF. So, that is equal to 1. So, corresponding RW is 1, because water table is below the base of foundation, but RW dash we have to calculate. So, for that calculation you have to know that dW dash by B, and dW dash is 0.5 and 0.5 and B is 2. So, this is equal to 0.25. So, if it is 0.25 around here, so corresponding to 0.25, the RW dash is 0.625. Okay. So, RW dash is 0.625. Okay. So, now we can calculate net ultimate bearing capacity. N square is 21 square, B is 2, RW dash is 0.625, then plus 300 plus 21 square into dF is 1.5, RW is 1. So, this value is coming out to be 995 kilonewton per meter square, but this is ultimate. So, we have to calculate the safe bearing capacity. So, Q net safe is 995 divided by the factor of safety, and that factor of safety is given 2.5, factor of safety is 2.5. So, this value is 398 kilonewton per meter square. So, considering only bearing capacity, the safe load this footing can take is 398 kilonewton per meter square. So, now we will use the settlement consideration. We have used only the bearing capacity consideration. Now, we will use the settlement consideration, because in, as I mentioned during the design, we have discussed the bearing capacity, then we have discussed the settlement, and then allowable is considering both the minimum of the safe load or the load the footing can take, considering settlement and bearing. So, we have considered the bearing capacity, now we will consider the settlement. So, settlement we use the IS method that I have discussed, because I have, as per for settlement calculation for granular soil, I have discussed 5 methods. So, the plate load test, SPT, SCPT, then the semi empirical method and the influence factor method. So, here I will use the SPT based method as per the IS 8009, where the settlement curve chart is here. So, settlement value, our width of foundation is 2 and n value is 25. Okay. So, the settlement value will be this one, 10 to the power minus 2 meter per kg per centimeter. So, the settlement that we are getting is 10 to the power minus 2 meter per kg per centimeter square. So, for 1 kg per centimeter square loading intensity, the amount of settlement is 10 to the power minus 2 meter from the chart we are getting. So, then because width of foundation is 2 meter and this is n value is 25, this is the 25 line, okay, n value is 25. So, we will get a value of settlement 10 to the power minus 2 meter. So, we will get for 1 kg per centimeter square load intensity, the settlement is how much? Is 10 millimeter. So, now if we apply 1 kg per centimeter square load intensity on that foundation, I will get a settlement of 10 millimeter. Okay. So, our permissible settlement is how much? Our permissible settlement is 50 millimeter, but this settlement we have not considered the water table effect. So, that water table effect we have to consider. So, here also that for 1 kg per centimeter square. So, this 1 kg per centimeter square actually is 1000 kilonewton, sorry 100 kilonewton per meter square. So, I can write for 100 kilonewton per meter square load intensity, settlement is 10 millimeter, because 1 kg per centimeter square is equal to 100 kilonewton per meter square. But this 10 millimeter is not the settlement considering water table effect. So, that water table effect we have to consider. So, what is the value of the water table correction factor? Because this is the, so settlement we are getting 10 millimeter. So, actual settlement will be more than that. So, actual settlement first we will calculate the water table correction factor. So, that correction factor is W dash. So, W dash, how we will get that? We will get D by B value. What is the B value? B value is the water table position from the base of the foundation. So, here we can write DFW or we can write this is equal to d, small d also we can write, this is d is equal to 0.5 meter. Okay. So, d is equal to 0.5 meter, b is 2, this is 0.25. So, w dash will be the same correction factors, because this is 0.25, this is 0.2. So, this is 0.25. So, this is the value which is again 0.625. So, w dash is 0.625. So, this correction factor chart is as per IS code. So, where if the footing water table has the base or above, it will be 0.5. Okay. So, here remember that when you design something, so we have to consider the worst condition, and worst condition that this correction factor is 0.5. Okay, because your bearing capacity you can reduce by 50% or settlement you can increase by 2 times, but here it is not 0.5, it is 0.625. So, that means if you are very sure about the position of the water table, then you use that position of the water table. But if you are not sure, then when you design any foundation, you consider the worst condition. That means, you consider your water table effect is at the base of foundation for this case, or at the surface, because at the surface you will get the worst condition for the water table position. So, if you are pretty sure about your position of the water table, if you are very sure about the position of the water table, then you consider that water table position, otherwise you consider it at the surface or at the ground surface. Okay. But here the water table position is specifically mentioned. So, that is why you have taken this position. So, that means the water table position. So, water table correction factor is 0.625. So, actual settlement will be will be 10 millimeter divided by 0.625. So, this will be 16 millimeter. So, after correcting the water table correction factor, we can get that 60 millimeter settlement we can get for 100 kilonewton per millimeter load intensity. Okay. So, and the permissible settlement is 50. So, 50 millimeter we will get for how much load intensity. So, and that will be 100 into 50 divided by 16, and that is 312.5 kilonewton per meter square. So, settlement consideration, the load or the stress that a foundation can take, such that your settlement of the foundation will be within the permissible limit, is 312.5 kilonewton per meter square. So, here the bearing your factor of safety will not apply, because this is based on the permissible settlement. So, from bearing consideration, your safe load is 398 kilonewton per meter square, and for the settlement consideration your stress is 312.5 kilonewton per meter square. So, minimum of these two will be the allowable bearing capacity. So, for allowable or Q allowable will be 312.5 kilonewton per meter square. Okay. So, to cross check that, now you use the another correlation, so that we can determine the allowable bearing capacity directly, because here in this case we have determined the bearing capacity, we have determined the safe load considering bearing capacity, and considering settlement separately, and then the minimum of these two will be the allowable bearing capacity. But if I use the another correlations where directly we can get the allowable bearing capacity. So, that correlations is given by that Peck, Hanson and Thorburn, (1974). So, there are few correlations are available. So, I am using this one, and where directly the Q allowable net we will get, and that correlation is 0.044 Cw n SA, and that is ton per meter square. Now, Cw is equal to 0.5 plus 0.5, and this is the your dW, and then dF plus B, where now the dW is this position, that means the from the surface, position of the water table from the surface. So, dW is equal to 2 meter. So, I can write 0.5 plus 0.5, 2 meter, 1.5 meter with a foundation also 2 meter. So, that is 0.786. So, you can see for based on the different correlations, we are also using the correction factor differently, because sometimes you are taking it from the base of the foundation, sometimes we are taking it from the ground surface. So, what are the recommendations? You have to use that recommendation as for the correlations that you are using. So, this is 0.786. So, but this all these things are you have to use if you are very sure about the position of the water table. Otherwise, for all the cases you consider the position of the water table is at the ground surface. Okay. So, now it is because here settlement is there, permissible settlement, and previous case also permissible settlement is or settlement is there. So, influence zone will be twice B, and the n value is will be the 25, because for settlement consideration n value is 25. So, Q allowable net will be equal to 0.044 into 0.786 into n is 25 into 50. Okay. So, this is the value. So, this value we are getting around this value will be getting around 400 plus, because it will be more than 400 or something. So, that means here the allowable bearing capacity that we are taking. So, that we are proposing is that is 312.5 kilonewton is correct, because when we are cross checking it by using the Peck, Hanson and Thorburn equation, that is given more than 400 or close to the 400 kilonewton per meter square. So, that means which is more than 312.5 kilonewton per meter square. So, we have discussed the three methods. One is the bearing consideration or the settlement consideration, another one directly the Q allowable net we are getting. Okay. So, but among these three, the settlement consideration is giving the lowest value. So, that is why this will be the allowable bearing capacity, and that we will use for our design. So, now you check the dimension that your footing you have considered is sufficient or not to take this much of allowable bearing capacity, or this your foundation you can apply this much of allowable bearing capacity, that is sufficient or not the load which is coming from the superstructure. If the load which is coming on the foundation is more than this allowable bearing capacity, then you have to redesign it. Or okay. So, but here it is only to calculate, because there is no checking option is available. So, only you have to calculate these things, these allowable bearing capacity. So, that is why this allowable bearing capacity will recommend by 312.5 kilonewton per meter square, or if you want to put it in round figure, you can put it is 300 kilonewton per meter square value. Okay. So, and if you know that the load which is coming on the foundation, the amount of load, then you can check whether that load which is coming from the superstructure is can be taken by this foundation or not. But here this load is not given. So, you can only propose the allowable bearing capacity of that foundation under this 2 by 2 cross section, and this is the value. Okay. If you have know the how much load is coming, then you can also compare also that with that load, that this much of load this foundation can take. If it is not sufficient this dimension, then you have to change the dimension for the next trial. Okay. So, this is the way we can determine the allowable bearing capacity based on n value. So, in the next class I will discuss that how we can design a shallow foundation on the clay soil, because here I have discussed for the both the cases, I mean for SPT and the for plate load test are for sandy soil. So, next class I will discuss the how we can design the foundation on clay soil.